We should always be thinking about is how do new things that we're learning connect up with previous things that we've already learned. And one thing that I want to ask right now is, how does Green's theorem connect with the loop property of conservative vector fields that we saw last section, section 16.3? So the loop property conservative vector field says, I'm going to state it, and this implies this, that if you have a conservative vector field, then the integral of f around every loop, every closed loop, gives you 0. Okay, well, Green's theorem right here is like, this is our line integral around the loop, is equal to this expression over here. How do these two things connect? Well, Green's theorem says that the integral over, Green's theorem is going to say integral of f dot dr is equal to the double integral over the region inside of the curve, partial derivative n with respect to x, minus partial derivative n with respect to y, dA. So now suppose that f is conservative, and so we know by component test for conservative vector fields, the cross partial derivatives need to equal. So if f is equal to mi hat plus nj hat, this tells us the partial derivative, I'm just copying this right here, partial derivative n with respect to x has to equal the partial derivative n with respect to y. Now, what does that tell us about this up here? Do we see these up here? If this is equal to this, then this right here is equal to 0. And so we are integrating over some region R. Who cares what that region R is? We're integrating a constant of 0, so of course we're going to get 0 as our answer. And so how does the Green's theorem connect up with our loop property? We would say that the loop property is a special case of Green's theorem. It's a mighty sorry looking green, but I hope you've been appreciating my effort into color fidelity there. Okay, so Green's theorem generalizes the stuff from the previous section. I guess I can put it this way, that if you have a conservative vector field, last section, section 16.3, tells you everything you need to know about line integrals if you have a conservative vector field. If you don't have a conservative vector field, Green's theorem still allows you to tell things. It tells you things like this right here. Okay, so that is how these connect up. Here's a pre-class problem for you to try. Verify Green's theorem for the line integral along the unit circle C. Orient it counterclockwise, center at the origin, where your vector field is y, x.